A while back, I sat in a room where a finished healthcare project couldn't launch. The model worked, the retrieval worked, the demo landed. Then someone from legal asked one question and the room went quiet. Where does the patient data go the moment a nurse types it in? Nobody at the table could draw it. We knew the code cold but not the data path, so we could promise nothing. That's the day I learned compliance isn't something you bolt on at the end. Compliance is a property of your architecture and a whole score domain on the professional exam. Foundations asked whether you could build the thing. This asks whether you are allowed to run it and prove it to someone whose job is to say no. Before you name a single regulation, you draw the data flow map. You mark where data is created, travels, rests, and who can touch it. A user types, it hits your service, and sound goes to the model. An answer comes back and you almost certainly log it. Every arrow is a place data lives and a place a regulator points at. The exam leans on this because wrong answers grab a control before drawing the flow. With the map, each regulation is just a lens over the same picture. 3 names come up again and again, so hold on to that number, 3. Start with GDPR, Europe's privacy law. It asks where personal data sits, whether a user's data can be erased, and whether you send more than needed. On the cloud platform, you can pin where inference runs and where your workspace data rests, which answers residency. Erasure and minimization stay your job since you decide what to send and keep. Next is HIPAA, the United States Health Privacy Law, turning on protected health information about a patient. Anthropic offers HIPAA-ready API access, and with a signed business associate agreement, you can process that health information under real safeguards. That means encryption, access controls, and audit logging around it for its whole life. Last is FedRAMP, the United States government's authorization program, and this is where architects trip. FedRAMP doesn't certify a model. It authorizes the environment the model runs inside, since the model is a software component and the room around it is what gets authorized. So the same Claude is compliant or not depending on which room you run it in. There are authorized paths built for this, and picking the right boundary is the decision, not a memo saying trust me. Now controls, because a map with no controls is just a drawing. When something must happen, you enforce it in code. When it merely should happen, a prompt can guide it. A hard compliance rule is always a must, so it never belongs in a prompt. Telling the model to please protect health information is guidance, and a regulator doesn't accept it. A policy document has never once stopped a byte of data from going anywhere. The real controls start with zero data retention, where the platform stores none of your prompts and answers after the reply. The rest are the signed agreement, reason pinning, and redacting sensitive fields from logs. And you put a human in front of any decision with real consequence. Logging everything feels like compliance, but a log records what happened. It doesn't stop it. When you need proof, read the audits which Anthropic publishes through its trust portal. That failure mode has a name, compliance theater, rules that pass a checklist while the system still does what's forbidden. This domain also asks about ethical AI, where ethics is architecture, scored like architecture. Bias testing is an eval, the same golden set idea from the evaluation domain. You spread cases across the groups you serve to see if one is treated worse. Transparency is a design choice, telling a user plainly when they're talking to an AI. Fairness is checking your accuracy holds across segments, not just the average user. Let me put this to work the way the exam will with 3 questions. These are original, in the blueprints style, not real exam items, and we eliminate on principle. A company serving European users builds an assistant over customer records. Legal requires personal data stay in an approved region, and any user's data be deletable. Today, they send whole records to the model and keep transcripts forever. Which change best addresses their data flow obligations? Add a system prompt line telling the model not to remember personal data. B. Pin inference and storage to an approved region send only the fields needed and make transcripts deletable per user. C. Upgrade to a larger model for the compliance reasoning. Leave it as is and add a privacy policy section describing the data use. Puts a hard rule in a prompt guidance the model can ignore. C. Reaches for scale where the design decision is missing. D. Documents the behavior while the data flows exactly as before theater. B. Fixes residency, minimization, and erasure at the layers that control them. So B is correct. A team processes protected health information through the Cloud API. To become HIPAA compliant, they add a prompt line telling the model to follow it. They also log every pull request, health data included, to a bucket. What's the correct architecture move here? A. Execute a business associate agreement, enable HIPAA-ready access, and stop writing raw health data to the log. B. The prompt instruction is enough. The model follows its instructions. C. Keep verbose health data logging, since more audit data is safer. D. Route health cases to a larger model that understands HIPAA. B. Trusts a prompt to enforce a legal must, the classic prompt as guarantee trap. C. Logs the very data the rule protects, an exposure dressed up as an audit trail. D. Swaps scale for the missing agreement and safeguards and changes nothing. Executes the agreement, adds real safeguards, and shrinks the footprint, so A is correct. A federal agency needs a workload that requires FedRAMP high. An architect proposes calling the public API directly and writing a memo asserting compliance. What's the right approach? A. The model is identical whichever endpoint you call, so the public API is fine. B. Add encryption in the application and declare the system FedRAMP compliant. C. Instruct the model in its system prompt to follow the required FedRAMP controls. D. Deploy through a FedRAMP high authorized boundary such as Cloud for government or a government authorized cloud because FedRAMP authorizes the environment, not the model. Fixes the wrong layer, treating authorization as a model property, not a boundary property. B. Does one real thing and asserts the rest, a memo standing in for authorization. C. Asks a prompt to satisfy a government authorization guidance where enforcement is required. D. Places the workload in an environment carrying the authorization, so D is correct. The one thing to answer before a regulated system ships is where the data goes, so draw the map. Then you lay the three lenses over that map: Europe's privacy, health under HIPAA, a boundary for FedRAMP. You enforce every hard rule with a real control, never a prompt and never an unenforced policy. And you treat bias, fairness, and transparency as things you measure and in design. If a rule matters, make the architecture unable to break it, don't just write it down. Because a compliant design still dies if you can't explain it, which is where defending it to stakeholders comes in.